Hello, my presentation topic is interfacing memory with 8086 microprocessor. Introduction of 8086 microprocessor. It is an enhanced version of 8085 microprocessor that was designed by the Intel in 1976. It has a 16-bit microprocessor and having a 28 address lines, and it provides a storage of 1 MB, or we can say that it has a memory of a 1 MB, 1 megabyte, and it provides the operation like a multiplication and division has a powerful instruction set. Now, memory hierarchy in 8086 microprocessor. So memory hierarchy is about arranging different kinds of storage device in a computer based on their size, cost, and access speed. So as we go upward, speed and cost per bit increases. First, CPU register, cache memory, primary memory, and a second memory. Now, types of memory. There are two types of memory: RAM and ROM. RAM, random access memory. It is used for the data and a program storage, and it is a read and write memory. And ROM is a read-only memory. It is used for the program storage and typically read-only memory. Now, the addressing modes of 8086 microprocessors. First, direct addressing mode. Direct addressing mode is explore how direct addressing modes allow the microprocessor to directly access the memory location. Now, indirect addressing mode. Dive into the concept of indirect addressing mode, where the microprocessor obtained the memory address from the register or the index register. Now, immediate addressing mode. In this type of addressing mode, source operand is a 8-bit or a 16-bit data. Destination operand can never be immediate data. For example, move AX 2000, move CL 0A, move AL 45, and AX 000. Now the register addressing mode. Register addressing mode. In this type of addressing mode, both operand and both the operands and registers are present. It directly specified using registers. For example, move AX BX copies the content of the BX register into AX register. Move AX DX, move AL BL. Now the memory addressing mode. Memory addressing modes are direct addressing mode, register indirect addressing mode, and indexed addressing mode. Fourth one is based addressing mode, and fifth one is a based indexed addressing mode. These modes involves accessing data in memory locations. In this mode, the operand is pointed to the register. And in this mode, operand is located at a specific memory address. For example, move AL. Here it is a given one example. Move AL 1234H loads the byte at a memory address 1234H into AL register. This mode combines a base register, usually BX or a BP, with the offset. For example, move AL SI plus DI loads the byte at a memory location pointed by the sum of SI and DI register into the AL register. Now, immediate offset addressing mode. It is a mode in which value is added to the register or the register pair to generate an effective address. Here example is also given. Move AL BX plus SI plus 10H loads the byte at a memory location and calculated as a BX plus SI plus 10H into the AL register. These addressing modes, all these addressing modes, but this immediate offset addressing mode provides a flexibility to the programmer, allowing for efficient memory access and data manipulation. Choosing the appropriate addressing mode depends on the specific requirement of an instruction and data being operated on. One more addressing mode, based index mode. In this, effective address is sum of a base register and index register. Base register BX and BP, index register SI DI. Interface Security. Databus is a set of electrical lines or a trace that allows the transfer of a data between the microprocessor and the computer system. Databus is used to send the memory address of an instruction or a data being read or written. It is a 16-bit wide, allowing the 8086 to address up the 64 kilobytes of the memory. Databus is used to transfer the data between the microprocessor and a memory. Width of databus determines the maximum amount of data that can be transferred into the single operation. For example, it writes the memory from external device to the microprocessor. Example, memory reads. Now the address bus. The address bus is another set of electrical lines or traces that are used for specifying the memory address when accessing memory or input-output devices. The width of address bus determines the range of memory address that processor can access, which in turn defines the maximum amount of a memory. Address bus is a unidirectional, meaning it is used to send address from the microprocessor to external devices. It allows the microprocessor to request data from write data to specific memory location. Memory segmentation. Memory segmentation is nothing which but the method where whole memory is divided into the smaller parts. In 8086 microprocessor, memory are divided into 4 parts, which is known as the segments. Segment and segment register. These segments are data segment, code segment, text segment, and extra segment. Segment and offset. Memory address in 8086 are specified as a combination of a segment and offset. The effective address is calculated as a segment into 16 plus offset. We can also say that it is the formula for the calculation of a segment and offset. Segmentation registers. The segment registers CS, DS, SS, ES holds the 16-bit values representing segment selectors. DS data segment register, stack segment register. These selectors are used to point to specific segment in the memory. Now, when an instruction is executed in the segmentation register, the CPU automatically uses the appropriate segment register to access the memory. Now, the real-world examples of interfacing memory with the 8086 microprocessor. Memory interfacing with Intel 8086 microprocessor has the many real-world examples. First, personal computers. In early days, personal computing 8086 based on computers used memory interfacing to connect RAM, ROM to various inputs. But in modern world, RAM interfacing allowed 8086 to access the memory, program execution, and data storage. And ROM interfacing enabled the processor to fetch BIOS, basic input and output system, instruction at a boot time. Now, industrial control system. In industrial automation, 8086 based microcontroller often use memory interfacing to connect to external sensors and actuators. It interface the circuit facilitate communication with the motor controller, sensors, and displays. RAM interface store data from sensors and process control algorithms. Now, the third application is embedded system. Many embedded systems such as ATM machines, vending machines, has in which the 8086 microprocessor is used. Memory interfacing in this system connects the microprocessor to program memory using a RAM or a flash. Data memory interfacing enables storage or transition data, logs, and configuration settings. Next application is communication equipment. Memory interfacing connect 8086 to buffer and data storage and controls the tables for efficient data handling. And also communication device like modems and routers may employ the 8086 microprocessor for controlling and managing the data transmission. Next is system. Some automotive engine control units use 8086 based microcontroller for tasks like a fuel injection and ignition control, where we can use 8086 microprocessor. Memory interfacing allows these ECUs to store loop tables, calibration data, and fault codes. Medical devices. In medical devices also we can use 8086 microprocessor. Medical instruments and devices often incorporate 8086 based microcontroller. Memory interface is used to store patient data, device configuration setting, and software programs. Next is gaming consoles. Older gaming consoles such as a Sega Genesis used 8086 based Motorola 6800 processor. Memory interfacing allowed for game program storage and data management. Next application is aerospace application. In some aerospace application, 8086 based microcontrollers have been used for the flight control system and the data processing. It also interface connect to the process to data storage, navigation data, and control algorithms. These examples illustrate the versatility of 8086 microprocessor and also interface and plays a crucial role in enabling the system to store the data, execute code, and many input and output operation effectively. So there are many applications mentioned, so which are used application of 8086 microprocessors. Now the conclusion. The present interfacing memory with the 8086 microprocessor explores the critical role in memory interfacing in enabling the Intel 8086 microprocessor to function effectively in various computer systems and embedded applications. The following are the key points which we have discussed in this presentation. Memory organization. 8086 uses a segment memory model, dividing memory segments with the base address. Segment register, as we have earlier discussed, that a CS, DS, SS, and ES point to these segments. Segmentation mechanism, memory types, which are mentioned, RAM and ROM. Data transfer, data bus which has a 16 bits and address bus of a 20 bits and has a storage of 1 megabyte. Practical applications, real world examples that we have discussed. Benefits and significance. Memory interfacing offers addressable memory expansion, efficient data storage, and code execution, data management, and input output operations. Thank you.